In this, I am going to solve numericals based on Biprism and Newton's ring. Numerical number 1. Let us read it. In a biprism experiment, the distance between the slit and the screen is 1.5 meter. To understand it, let me draw first the experimental setup diagram for the biprism experiment. At this point, there is a slit, or you can say the source S. At this point, there is virtual source S1, and at this point, there is virtual source S2. Here is the screen, and this is the biprism. This is screen, and here there is a slit or source. Now let's see what is given. The distance between slit and screen is 1.5 meter. So this distance is given, and this distance we are representing by the letter D, capital D. Capital D is given here, which is 1.5 meter. Then let's read further. The biprism is 0.25 meter away from the slit. So another distance is the distance between the source and the biprism. This distance is given. Let us call it A. And so A is given here, which is 0.25 meter. And its refractive index is 1.55. Refractive index of the biprism is 1.55. Then, when a source of wavelength 632.4 nanometer is used, so the wavelength is given, which is 632.4 nanometer. We want it in meter, so into 10 raised to minus 9 meter. Then the fringe's width is 0.2 mm. So beta is given here. Beta is 0.2 millimeter, which is nothing but 2 into 10 raised to minus 4 meter. And what we have to find is the angle of biprism, that is the theta. We have to find obtuse angle. To find obtuse angle, you also have to find alpha, which is acute angle. To solve these numericals, we are going to use the formula of beta, which is equals to capital D into lambda divided by small d, and small d is equals to 2a into bracket mu minus 1 into alpha. These two formulas we are going to use. So let us first find small d using the fringe width formula. So here the small d is equals to d into lambda divided by fringe width beta. D is given, which is 1.5 meter. So 1.5 into lambda is given 632.4 into 10 raised to minus 9 divided by fringe width beta, which is 2 into 10 raised to minus 4. All units, all the constant here are in MKS system. After solving this, we get 4.743 into 10 raised to minus 3 meter, or you can say it is equals to 4.743 millimeter. that is d. Small d, as you know, it is the distance between the two virtual sources. This is small d. And we found small d is equals to 4.743 millimeter. Then we have to find the acute angle using this equation. So for that, alpha is equals to d upon 2a into bracket mu minus 1. Alpha, just now we got the value of alpha, which is 4.743 into 10 raised to minus 3 meter divided by 2 into A. A is given here, the distance between the source and biprism, which is 0.25 meter, into mu is 1.55 minus 1. And after solving this, what we get is 17.25 into 10 raised to minus 3, but this is in radian. And we have to convert this radian into degree. So here alpha, which is 17.25 into 10 raised to minus 3 radian, that equals to 17.25 into 10 raised to minus 3 into 180 divided by pi. So this will be converted into degree, which comes approximately equals to 0.99 degree. And this 0.99 degree is now the value of alpha. In the biprism, as you know that this is the obtuse angle theta, and these two angles are alpha. This is alpha, this is alpha. So obtuse angle theta is equals to 180 degree minus 2 alpha, that is 180 degree. Now instead of 180 degree, I will write here 179 degree and 60 minutes. 60 minutes means 1 degree. So it is actually 180 degree minus 2 alpha, 2 into 0.99 degree. So let us write, instead of writing this into degree and minutes, let us write only in the degree, that is 180 degree minus 2 into 0.99 degree, and that is equals to 178.02 degree, and that is the answer. So obtuse angle of this prism is 178 degree, and that is the answer. Then let's go to the numerical number 2. Numerical number 2. The bands of 0.2 mm width are observed at a distance of 1 meter from the slit. Let's try to understand. A bands of 0.2 mm. It means, let me draw first the diagram for better understanding. This is the prism here, and by prism, here is the screen, and at this point there is source S, source S1, source S2, and the distance between virtual sources is, as we know, is small d. So the bands of 0.2 mm width, it means that beta is given, which is 0.2 mm, which is nothing but zero point 0.2 into 10 raised to minus 3 meter. And observe at a distance 1 meter from the slit. So the capital D is also given here, 1 meter from the slit. That is, slit is the source, and that distance we are denoting by capital D. And here the value of capital D is given, which is 1.0 meter. Then let's read it further. A convex lens is then put between the observer and the prism. So in this case, there is a convex lens is there in between by prism and the screen, so as to give an image of a source at the distance of 1 meter apart from the slit. So by putting that, we are getting the image of the virtual source S1 and the image of the virtual source S2 on the screen, which is 1 meter apart. That is a capital D, which is 1 meter. When the lens is at a distance of 0.3 meter from the slit, so we know that the distance between source and the lens, we are denoting it by letter U, and the distance between lens and the screen is denoted by V. And in this case, the lens is at a distance 0.3 meter from the slit. So the value of U is given here. U is equals to 0.3 meter. And you can see in the diagram U plus V equals to D. D is 1 meter. U is 0.3 meter. And so the value of V is equals to 0.7 meter. Then the distance between images in the micrometer eyepiece is 7 millimeter. So here this is small d, 1. That is the distance between the re real images of virtual source S1 and S2. So here D1 is given, which is equals to 7 mm, that is 7 into 10 raised to minus 3 meter. Calculate the wavelength of light. What we have to calculate is lambda. We have to find the wavelength. The formulas which we're gonna use in this case is the magnification formula, which is d1 by d, d1 by d, d1 by d equals to v upon u. And what we have to find is small d. Therefore, small d is equals to d1 into u divided by v. d1 is 7 into 10 raised to minus 3 meter, u is 0.3 meter, and v divided by v, which is 0.7 meter. And so the value of d is equals to 3 into 10 raised to minus 3 meter. That is 3 millimeter is distance between the two virtual sources. So we got the value of D, but we have to find the wavelength. So we have the formula wavelength lambda or the fringe width beta is equals to lambda into capital D upon small d. Therefore, lambda is equals to beta into small d divided by capital D. We know the value of beta. Beta is zero point 0.2 into 10 raised to minus 3 meter. D we just measured 3 into 10 raised to minus 3 meter divided by capital D. This one is 1 meter. So this is equals to 6 into 10 raised to minus 7 meter. That is nothing but 600 nanometer. So we got the wavelength of the source, and that is the answer. Let's go to next sum. Sum number 3. Obtuse angle of biprism is 178 degree 40 minute and its refractive index is 1.5. A slit is illuminated by a light of wavelength lambda situated at 0.1 meter from the biprism, and the fringes are observed at a distance of 1 meter from it, having fringe width of 0.0006 meter. Calculate the wavelength of the light. Again, let us first draw the diagram to understand the numerical. So here is the biprism. Here is the screen, and here is the source S1 and S2. What is given? Let's write what is given. Obtuse angle is given. That is theta is equals to 178 degree 40 minute and its refractive index is 1.5. Refractive index is 1.5. A slit is illuminated by light of wavelength lambda situated at 0 0.1 meter from the biprism. So in this case, the distance between the source and the biprism is given, which is equals to A. So A is equals to 0 0.1 meter. And the fringes are observed at a distance of 1 meter from it, that is from the biprism. So this distance is given. Let us denote it by the letter B. B is equals to 1 meter. And our D is nothing but A plus B, which is distance between the source and the screen is capital D. So capital D is A plus B, A plus B. So capital D is 1.1 meter. Having fringe width 0.0006 meter. Fringe width is also given 0.0006 meter, that is 6 into 10 raised to minus 4 meter. And what we have to calculate is wavelength. We have to find wavelength. lambda. But to find wavelength lambda, we have to find first what is the angle alpha, and from that we can find small d. So we know that theta is equals to 180 degree minus 2 alpha, or alpha is equals to 180 degree minus theta upon 2. So here, instead of writing 180 degree, I will write 179 degree and 60 minutes. That is nothing but 180 degree minus theta is 178 degree 40 minute divided by 2. So this is nothing but 1 degree 20 minutes divided by 2. 1 degree 20 minutes is 80 minutes divided by 2, and that is equals to 40 minutes. This 40 minutes, alpha is equals to 40 minutes, which is equals to 0.667 degree. And I want this in radian. So I will convert this into radian. So this is equals to 0.667 into pi upon 180 radian. So this is equals to 1.164 into 10 raised to minus 2 radian. So I got the value of alpha here, which is 1.164 into 10 raised to minus 2 radian. Then I will use this equation. D is equals to 2a into bracket mu minus 1 into alpha. I want to find this small d. So this is equals to 2 into a. The value of a is 0.1 meter. So 0.1 into bracket mu minus 1. Mu is 1.5. So 1.5 minus 1 into alpha. 1.164 into 10 raised to minus 2. So this is nothing but 1.164 into 10 raised to minus 3 meter. So I got the value of small d, which is 1.164 into 10 raised to minus 3 meter. What I have to find is actually lambda. So the lambda is equals to beta into small d upon capital D. Beta is 6 into 10 raised to minus 4 meter into D is 1.164 into 10 raised to minus 3 meter divided by capital D, which is 1.1 meter, and that is equals to 6.35 into 10 raised to minus 7 meter, or 635 nanometer is the wavelength. Then numerical number 4. It is on the Newton's ring. In a Newton's ring experiment, diameter of 12th dark ring changes from 0.48 centimeter to 0.39 centimeter when a liquid is introduced between the lens and the plate. As you are aware that in case of the Newton's ring, there is a plano-convex lens. This plano-convex lens is kept on a glass plate, and a thin air film is formed between this plano-convex lens and the glass plate. So what is given here? Diameter of 12th ring with air film is given. Diameter of 12th ring with air film, which is 0.48 centimeter. And we can write the equation for this diameter of the dark ring. You know that diameter square of the 12th ring is equals to 4n lambda r. Let us say this is equation 1. So this diameter, which is 0.48 centimeter, when the film is air, changes to 0.39 centimeter when the film is replaced by the liquid. So diameter of 12th ring with liquid is 0.39 centimeter. So equation for that, now there is a liquid whose refractive index is mu. Then d dash square of 12th ring is equals to 4 n lambda r divided by mu, and this is our equation 2. Then let's do equation 1 by equation 2. Equation 1 divided by equation 2. So equation 1 divided by equation 2. Then you get mu is equals to diameter square of 12th ring with air film, diameter square of 12th ring divided by d dash square of 12th ring. D dash is the diameter of 12th ring when the film is liquid. So 0.48 square divided by 0.39 square, and that comes equals to 1.51. So refractive index of the liquid is 1.51. Now what is asked is calculate the refractive index of the liquid and wavelength of the source. So we got the refractive index. So we have to find the wavelength of source when capital R is equals to 80 centimeter. Radius of curvature of lens is 80 centimeter, and we have to find the wavelength lambda. So we can use any equation. We can use equation 1 or you can use equation 2. Let us use equation 1. So d square of 12th ring is equals to 4n lambda r. We have to find lambda. Therefore, lambda is equals to d square of 12th ring divided by 4nr. So d square of d is 0.48. So 0.48 square divided by 4. N is 12. Is a 12th ring. N is equals to 12. So into 12 into R. R is 80 centimeter. So all the units are in centimeter, that is in CGS system. And this comes around 6 into 10 raised to minus 5 centimeter. So wavelength of the source is 6 into 10 raised to minus 5 centimeter, which is equals to 600 nanometer. Let's see the now numerical number 5. Let's read it. Newton's rings arrangement is used with a source emitted two wavelengths 6000 angstrom and 4500 angstrom. Two wavelengths are given here. Lambda 1 is 6000 angstrom and lambda 2 is equals to 4500 angstrom. It is found that nth dark ring due to wavelength 6000 coincide with n plus 1th dark ring due to wavelength 4500 angstrom. If the radius of curvature of lens is 90 cm, find the diameter of the nth dark ring due to wavelength 6000 angstrom. So here R is given 90 cm and diameter of nth ring due to lambda 1 is given by diameter square of nth ring is equals to 4n lambda 1 r. This is our equation 1. And diameter of n plus 1th ring due to lambda 2 is diameter square of n plus 1th ring is equals to 4 n plus 1 lambda 2r, and this is equation 2. Now diameter of nth ring due to wavelength lambda 1 coincides with diameter of n plus 1th ring due to wavelength lambda 2. So this is nothing but diameter of nth ring is equals to diameter of n plus 1th ring. Diameter of nth ring due to wavelength lambda 1 is equals to diameter of n plus 1th ring due to wavelength lambda 2. So we can equate 1 and 2. That is, diameter square of nth ring is equals to diameter square of n plus 1th ring, which is 4n lambda 1 r is equals to 4n plus 1 lambda 2 r. Let us simplify this. 4n lambda 1 r is equals to 4n lambda 2 r plus 4 lambda 2 r. So this 4 cancels with this 4, r cancels with this r, and what we get is n lambda 1 is equals to n lambda 2 plus lambda 2, which is therefore n is equals to lambda 2 upon lambda 1 minus lambda 2. Let us substitute the value of lambda 1 and lambda 2. Lambda 2 is 4500 angstrom divided by 6000 minus 4500 angstrom, and that is equals to 3. So this is the third ring. So diameter of third ring. So you can find the diameter of the third ring due to wavelength 6000 angstrom. So we can put this in this equation. Diameter square of the third ring is equals to 4 into n into lambda 1 into r. That is 4n lambda 1 r, which is equals to 4 into n is 3, lambda 1 is 6000 angstrom. So we can write this 6000 angstrom in the centimeter, that is 6 into 10 raised to minus 5 centimeter into r, which is 90 centimeter, and we get 0.648 nanometer, which is the diameter square of the third ring. So let us take the square root on both sides. Then diameter of the third ring is 0.81 centimeter, and this is the answer.